Hello. Today I'll be showing you how to do a simple Crackme from Crackmes.1. Now this is one by this author, and he calls it hidden. It's written in C/C++. It's multi-platform, which means it likely doesn't have any dependencies when opening it in Ghidra or IDA. It has difficulty of 1.8 and a quality of 4.5, and it's ran on x86-64 architecture. Now the purpose is to find the hidden password. Now, after you download it, which I've already done, you'll get a zip file like this, and all you do is you have to extract it, and then I guess I'll just pick a random directory. I'll put it under music, and here. Generally, when you first download this, you'll be asked for a password, and the password for every Crackme on Crackmes.1 is Crackmes.1. There. Now, after you have the file downloaded, you'll notice that it seems to be just a normal file, meaning it's not a PE executable. This likely means that it's an executable for Linux, as Linux files and generally Linux executables don't have any file extension. Now, once you have the file installed, what you can go ahead and do is open Ghidra, go under File, create a new project, and then go through the process of setting up the directory where the project will be stored. After that, you can click here for the decompiler, or I'm sorry, for the disassembler, and then once that is opened here, you can go under File, and then Import File, and that will be the executable that you would like to analyze. I've already done that, so just assume that you generally start in an entry point, which is usually setup code for the actual program that is ran by the system, but that isn't really useful for us because that doesn't go into what the author programmed. So what we can do instead is go under search and then search for strings, or I'm sorry, search for strings, and then we can go for the default settings. What this will do is go through the program and look for any ASCII strings that may be readable. This is why we have a minimum length of 5 to avoid any junk bytes that just happen to be readable. So we can go. Now, if you'll remember, the purpose of the program was to find a password. We can see here that some of the strings relate to this password. Let's go with this one. Please provide a password. Now let's close this. We can see that somewhere in memory, there is a string stored that is hard-coded called please provide a password. There is a reference to it at main, so let's click there. Now, because Ghidra identified this as main, we can just go ahead and scroll to the top of the function. This may not always be the case, so if Ghidra doesn't identify the function as main, then you can go ahead and just look at indicators such as the number of parameters, calls to different functions, the return value, different stuff like that. Now let's go into the actual program itself. Now here it looks like we set up the stack frame and set it to 30 bytes. Here it looks like we initialize some local variables. Because we don't know what is at EDI and RSI right now, it's kind of irrelevant at this point. We can just assume that this is initializing some local variables. From here, it looks like we take the value that is stored in local 2C and compare it to 2. And then we do a jump. Now here we can see in my comment that I put, based on this, we can determine that this local 2C is argc. Now why can we assume that? That's mainly because of this jump here. This is checking to see that this local 2C compared with 2 is looking to see if this is equal to 2 or not. If it is, it'll take this jump here to this branch. If it isn't, it'll go into these instructions. Now, what is this doing? It seems to be loading the address to this string into RDI and then outputting it to standard output. It then moves 1 into EAX and calls this unconditional jump branch. Now what is this string? It seems to be please provide a password. That means that the user didn't provide a password. So it seems that in this branch, the program will output for the user to provide a password and then take this jump. Now this just looks like an exit function we call leave and then return. So we can brand that as such for future reference. Now let's go back here. Now we're here at this branch, so we can also assume that this branch is if the user uses the program correctly. So we can also name that. So here, it looks like what we're doing is storing the value at local 38 on the stat frame into RAX. We then move 8 bytes from local 38 into RAX. Now, then we save that local value of local 38 plus 8 into a local variable. Now we do that by getting the value from RAX, storing it here into local 18, and then for some reason storing it back into RAX. This is just like a little quirk from the compiler. Now here it looks like we're passing this value of local 18 that is stored in RAX into RDI and then calling string length on it. It looks like this local 18 is actually a pointer to a string. So what we can do is rename that. So it makes sense here. We're passing the pointer to a string into string length and then getting some value back. Now because string length returns the return value or the return flag into RAX, we can assume that this is the length of the string. Now after we store that to a local variable, we compare that to 4. Here, after we do the compare, we go into a jump. Now it looks like we're checking here is to see if this value that we got from string length is above 4, or which means either equal to or greater than 5. Now this indicates, so based on that we can write this. And now let's assume that the password is less than 5. It looks like the address to this string is passed into RDI and then output to standard output with puts. And then we take this branch. Let's see what's going there. Now this just looks like a different type of exit, because we execute this instruction and then go into the exit program branch here. So that just looks like another type of exit, it possibly returns a different exit code. Now, assuming that the password we passed is equal to or greater than 5, we'll then go into this branch. So here it looks like we pass the pointer to the string into RAX, then add 2 to it. Now if you'll remember, strings are 0 indexed. So this is really accessing the third byte of the string. Because if we go, let's assume that this P is 0, 0, 1, 2. So the third byte. It then looks like we take this third byte and store it into the 32-bit lower register of RAX, which is EAX. And we're going to store it with 0 extended, which means a bunch of zeros on the left side for the MSB, and then our single byte and in the LSB. And then it looks like we take this value again and store it into EAX again, but this time we're going to sign extend it, which is likely preparing it for some sort of signed arithmetic. Looks like here we do the exact same, but here we add 3 to the address, which would mean we're accessing the 4th byte. So 0, 1, 2, 3, here, this 4th byte. Now it looks like we do the same of storing it into a lower register and setting it up to be signed for signed arithmetic. And it looks like that's what we do here. It looks like we take argv1, which is the password, its 3rd byte, and subtract it with its 4th byte, and then compare to see if the result is 20 in hex. Now this is kind of a strange relationship. Because we are passing ASCII bytes, we can look at an ASCII table and see which 2 characters are exactly hex 20 bytes apart. Now if you're familiar with ASCII, you'll know that is the relationship between uppercase letters and lowercase letters, because the difference between the two, one is on the in the hex 40s, the other is in the hex 60s. Usually, the relationship will be hex 20. Now that we know how, okay, so assuming that the third and the fourth byte are subtracted and the result is a hex 20, it looks like we'll take. Now this is the branch we'll take if our result is not hex 20. Let's see what that is. That just looks like an incorrect password branch. But assuming we do get the correct password, it looks like we get the print statement, "You are done with puts." And then what happens? And then it just looks like it exits the function. Now that we know how the logic works, we can go ahead and test it out. I will have to run this in a Debian VM. So here, let's just open a terminal. I've already went ahead and installed the executable and set it to an executable file. I gave it executable permissions. Now let's just try and run it without any parameters. Now here we'll see that we get that branch that we thought of, which asks the user to provide a password. This is checking to see if argc is 2 or not. Maybe let's try to add more parameters. See, we get the same thing. Because argc is not 2, it asks us to provide a password. Now let's just try to add some password that is greater than 5 bytes. So we can just do A, C, D, E, F, G, H. You'll see incorrect password. Now we do know the logic of how the password checking works. It looks for that hex 20 difference between the third and fourth byte. So what we could do is just add junk bytes for the first two, and then we can get the higher level or the higher value character, which would be a smaller or lowercase letter. So we could do something like lowercase z, and then get what's 20 characters below that, which would be a capital Z. And then to fit our length minimum, we just add another 2 bytes. Now let's see if this works. Looks like that worked. So it looks like there is no password. The password that we need, quote unquote, is just any string that is greater than 5 bytes and whose third and fourth byte are exactly 20 hex bytes apart, which, as we can see, is really just any combination of a lowercase letter and a uppercase letter. We can try it with other ones as well. We could even try it with the X's. You are done. Now that's really it. If we go back into Ghidra, we can see that this is really all of the logic that the program has, and the solution is really just any string with the combination of a lowercase letter and the uppercase version of that letter in the third and fourth byte. Thank you for watching. Thank you for watching, and if you like this, check out my links, my LinkedIn, and my GitHub.